So let's go ahead and jump in. So we're at 2:34 right now, and um, we've got until 4 o'clock and no later than 4 o'clock. So let's get to it. Let me share my screen, whole thing. All right, there we go. So where we left off yesterday, we were looking at how to create flags for students. And we used a function called if then. So I want to start back at that point because that's probably when people's heads were starting to explode. So I'm going to start back at that point and show how we can have Excel count the number of students that meet a certain criteria. So let's take a look at, actually, I'm going to do this with the big data set. So let me switch over to that. So this is the one that has 3,108 students in it, I believe is the count. So what I want to do is I want Excel to tell me how many kids took under a certain amount of time on their test. Which kids just rushed through it and didn't take enough time. So I need to do a couple of things. First thing I need to do is I need to create a flag for those students that didn't take enough time. And then I need to count how many students just got flagged. So let me move some things around on my screen here because I'm going to need them. And yeah, that'll work. Actually, you know what? I think I'll just tuck that to the side over there. Okay, so here we've got all of our students and scores and grades, but down here we've got the amount of time. How many minutes do they actually spend on the test? So the first thing I want to do is I want to create a flag for students that didn't take enough time. And I'm going to make this simple on myself. So let me start by creating a new sheet. And I'm going to just determine how much time is the minimum amount of time that I want students to take. So let's just call this minimum time. And I'm going to put over here a number. Let's call it 20 minutes for now. Okay. So I'm going to name the cell. You're going to see that pretty much everything that we do, because it's so complicated and so much extra work to have to refer to this cell and that cell, I pretty much name everything by the names that make sense to me. So let's go up here to the name up in the upper left where my cursor is flashing right now. Currently the name is B2, but I'm going to give it my own name, minimum time. And let me also color it so I know that's a named cell. Not required, but it helps me keep it straight. All right, so right now I'm saying the minimum amount of time that I want students to take on the test is 20 minutes. And anybody below that time, I want to flag them and count how many kids didn't take enough time. So there's my minimum time, 20 minutes. All right, back to my data sheet. So let's create a new column. I'm going to simply right click on T to bring up my little menu over here, and I'm going to say insert. Whenever I insert a column, it will always insert to the left of wherever I'm currently active. So I was active at T. It's going to move everything over to the right, and it's going to give me a new T. So let's just call this time flag. All right, pretty simple now. So we're going to use our if then, and this is where we left off yesterday. So the command is called, the formula is called if. And the way it works is I'm going to say if, and then I'm going to test for some condition. And I'm going to ask if is this condition true or not. If it is true, then if true, do this. But if it's not true, otherwise or else, do this. So I've got three things that I need to tell Excel. First of all, I need to tell it, what am I testing for? What am I looking for here? And is it true or not? If that condition is true, I'm going to do the first action. And if it's not true, I'll do the second action. Okay, so what do I want to know? Well, I want to know if the time the student spent is greater than the minimum time that I declare. And if it's true, if it is greater, don't do anything. I only want to flag those kids that are below that amount of time. So to indicate that we put nothing in that cell, we're not going to put a word, we're not going to put a number, we're not going to put a formula, we're not going to put anything in there. To indicate put nothing, it's simply two double quotes like that. But if it's not true, if the time is not greater than the minimum, then I want to put in some kind of an indicator to say that kid's been flagged for not being over the minimum required time. Okay, so let's see how this works here. And let me blow that up just a hair more. So I'm going to say if this value, this time right here, is greater than the minimum time, and I've already declared what that is. I've got a cell called minimum time. So if it's greater than that amount, then do what? Don't do anything, right? But if it's not greater than that time, I want to put in a word flag. And we see that that student is just fine. So now I don't want to have to rewrite that formula for every single student because frankly, I don't have that kind of time and it would be nuts. I don't want to do anything manually if Excel can do it automatically for me. So let's make Excel do that. I want to take that formula and copy it down all the rows. Well, I can just click and start dragging to select all of those. But if I do that, it's going to scroll really fast. And there's a very good chance that I'm going to end up going way past the point where I needed to go to. But Excel does give us a trick to do this, which is lovely. We can use that shift key, just like we did yesterday, to select the range. Remember, if we hold down the shift key, it will select a range of cells. So I'm actually going to start at the I'm going to go there. Okay, that one is selected. And if I shift and click in another place, it's going to select everything from the first point to the place where I click next. And this works on Word also. If you click on one point in your text and you shift click somewhere else, it will select everything between those 2 points. So we can use that to make it much easier to copy this formula. So right now we've got the formula in this first cell. So what I'm going to do is I'm going to use my little scroll bar. I'm going to go to the bottom and I will shift click here at the bottom. And when I do that, everything in between will be selected. So as you see, it's now all selected. So I've selected everything. Well, to copy my formula down, Control D or Command D. And that formula now is in every cell going all the way down to the bottom. And as you'll see, we do have some students who are flagged. Now, I could have just put the number in there. Instead of saying minimum time, I could have just put it in there. But what if I change my mind later? And I don't want 20 minutes to be the minimum time. What if I want it to be 30? Well, then I would have to go back and rewrite the formulas for every single row, or rewrite one and then copy it down and change the formulas. But because I have a cell called minimum time, I only need to change that one place. Because right now it's saying, okay, go and look at this value in the cell called minimum time and compare the student's time against that time. If I want to change all of these flags for a new amount, I only have to change one place. Let's make it 30 minutes instead. And now when it tries to compare, it's going to use the new value. So let me show you an example. So right here, this student right here has 32 minutes, okay? And there's no flag. But if I change minimum time to say 40 minutes, that student is now flagged because I don't have to change the formula. All I have to do is change the place the formula is looking at, which is minimum time.
Super quick question.
Yes.
Should be easy. How does it will look at all the sheets you have for that because it's pulling from a different sheet.
Yes.
Thank you.
Yep, it sure will. Because minimum time, we're at whatever sheet it's on, it doesn't matter. It's in this workbook. You can actually look at a different workbook if it's open. It's more complicated than we need at this point, but it can actually do it. But if it's in this worksheet, there is one cell somewhere in this worksheet, on some sheet, somewhere in this workbook called minimum time. And it's always sheet 2, in this case, sheet 2 and cell B2. So that makes it very easy. That's why in so many cases, I'll have all my data over on one sheet, but I'll have a nice clean sheet, another sheet with all of my results and formulas and stuff like that. And it will refer to any sheet in the workbook. So let's just change that back to 30. Okay. And we'll see this student is no longer flagged because it's still looking over at the value in minimum time, which is now 30. Okay. So the question we're trying to get to is how many kids didn't spend enough time? Anything, pretty much anything we do with Excel, when we're doing any kind of analysis, and this is just coming from, I don't know how many years I've done program evaluation and so forth, a lot of years. I know for sure that any analysis always starts with asking a question. And if we can define the question clearly, it becomes pretty simple then to set up the analysis or whatever we need to do. So the question here is how many kids didn't spend enough time? So we've flagged all of those kids. Now we just simply need to count how many flags. Well, all of these flags are in one column. They're all in one range from here all the way down to 31, row 3109. So let's make it easy on ourselves. Let's name that range. So I'm going to start at the top, shift, end, down to select the whole range. Now, when you do the end down or the end across or function for the Mac folks, I believe, it's going to go to the next. If you start on an empty cell, it goes to the first cell that has something in it. If you start on a cell with something in it, it goes to the last cell with something in it. Okay. Well, these are all blank, but there is something in them. You just can't see it. It's the formula. So even though they look like they're empty, they're not. They've got a formula in them. So I can use my little keyboard shortcut to select that whole range at once and give it a name. So shift, end, down. And the whole set of data, the whole column with information in it are now selected. Okay, let's give it a name. And let's call this time flag. So whenever I refer to time flag, it's always going to be this information right here. So all I need to do now is figure out how many flags are in that range called time flag. And see, that's why I said it's so much easier just to name your ranges and to name your cells, because then I don't have to go back and say from T2 through T2109 or whatever it is. Just whatever's in that range called time flag, that's what we're counting. So we're gonna say how many flags, right? We're going to use a very special counting formula. So yesterday, we don't need this one. Yesterday, we used something called count A, which is count all of the cells that have something in them, anything at all. If I do a count A on this new range, every single cell has something in it. It has a formula in it, right? So it's going to give me the wrong number. What I want to do, I don't want to count all the cells. I only want to count the cells if they have the word flag in them. And I do that with something called count if. Count them if they meet a certain criterion. And this is what it's going to look like. So there's my formula name. And now I need to put in the parameters. Well, the first parameter is where are we counting? The next parameter is what is the criteria? And I need to tell Excel only those two things, and it will return the answer I need. So in this, not count in, silly guy. There we go. So I'm going to look in that range, which is, what did I call it? Time flag. Okay. So I need to look in the range called time flag, right? That's where we're going to look. And what am I looking for? I'm looking for the word flag. So the count if then will look through the whole range called time flag, and it will count the number of cells that say flag. Well, let's use that. So equals, let me blow it up a little more.
Question, does it
Yes.
care about capitals and lowercase?
No.
Thank
It
you.
does not. Yep. Anything works. Well, certainly if you can use capitals or lowercase or any combination for the name of the formula. I believe it's also true. That's a good question. I think it doesn't care about capitals at all. But let's test it. Okay. Count if. So we're going to look in the range called time flag, and we're going to look for the word flag. Oops. Do you need to go back and do that? I heard a camera phone going off. There we go.
Sorry.
So that's fine. So let's see how many kids got flags. 1,263 students got flags, which is a lot of kids. Now, I'm going to test your question. Count if time flag. I know it doesn't make any difference there. And there's your answer. Here we used capitals. Here we did not. And we got the same result.
Thank you.
Yep. So here's what's interesting about this. The number of flags depends on this value right here called minimum time. If they're over minimum time, no flag. If they're at or below it, they get a flag. And then these down here count the number of flags. So if I change the minimum time, the number of students with flags should change, and the number of flags would then change. Let's try it. Let's put in 40 minutes. And now we have 1,898 students. 20 minutes, 586 students. So you can see how they're linked together. This number right here changes whether or not the word flag is going to show up over here, and the number of flags is going to change my count over here. So that's, if I'm looking at data, I want to know, first of all, is this a valid score or not, right? If I'm going to look at somebody's test scores, I need to know, should I even be counting it? Is it valid? Because if it's not valid, if a kid only took, if we have kids that only took 10 minutes, I don't want their scores to affect my evaluation as a teacher, right? Because the kid didn't take enough time. So his score, I can't rely on it as being a true indication of whether or not he's learned anything, because he just rushed through the test. If he did it really, really fast, there's a pretty good chance that the test did not measure how much the student knows. So that becomes very important. So I want to know, if they didn't take enough time, I don't want their scores to be included in the average growth of the students. So it's important to me for that reason. So by doing this little system right here, I can easily say, you know what? These kids, this one with only 7 minutes, didn't take enough time on the test. So when I'm looking at my average scores, I do not want to include that student's scores, because it is not a good measure of that student's achievement. Okay, so far, are we okay so far?
Yeah, this is really useful, David. I had a quick question too.
Okay.
I was wondering if you can use the if-then formula for dates. So, like if you're wanting to measure if something's past due or something like that, flag those things.
Yes, which is actually pretty good. When did the kids test? Just, what we would look at here, right? So yes, you can. Every date in Excel is the equivalent of some number. So for example, we've got this student started on April 5th, 2015, right? So it's formatted as 4/5/2015, but there's actually a number there. Let me just convert it to a number. 4/15/2017 is the same as 42,830, which is actually the number of days since January 1, 1900. And the 0.00 is what fraction of the day, hours and seconds and so forth. Okay. So when Excel looks at dates, it's not looking at 4/5/2017. It's looking at 42,830.00, which is a number, which means that we can actually do calculations on dates. Let me show you something very, very quickly. Let me just insert something here, because this often comes up, did the student take it in the right amount of time? Today's date, if we want to know what is today, it's equals now, with no parameters, just now. Oops, and it's too big to fit. So right now it's 10/8/2020 at 2:57 in the afternoon. Okay. So we can always compare a date to now. So we can do equals this date minus this date. And let's change it to a number. It'll tell us how many days. There's a much more sophisticated way to do this, but basically it's been 1,282 days since that kid tested. Let's say we want all of the tests to be completed before a certain time. So let's say we want the students, and I'm only going to do one, then we're going to move on. Okay, we're not going to do what we did yesterday and get too far into the weeds, I promise. So let's say we wanted all the kids to test before 5/1 2017. Okay. So we're going to compare these dates against that date there. So all I need to know is equals if this date right here is less than or equal to this date, then put in the word on time. Otherwise, put in the word late. And let me close it. Did I do it backwards? Greater than or EQ to, oh, I did it backwards. My error. If this is greater than or equal to that, there we go. That student was on time with the test. But let's say the closing date was 4/1/2017, right? Well, if the kid tested on 4/5, it should be late because they tested after that date. Sure enough. So yes, you can do comparisons of dates, and you can use an if then to check the date of the activity against some date, a due date that you have specified.
Awesome, thank you.
Okay. Yeah. Because the fact is, dates are numbers too. So Excel can do things with them. All right. And this one is always very useful. Now, it is 3 o'clock. Exactly. Okay. Whew. Let's get rid of this one. And let's go back to our small data set. And let me see where we are. Okay. So you see I've got a column on here called valid, because that really is an essential question when we're doing any kind of analysis of student scores. Do we or do we not include them in our analysis? Do we or do we not include them in our evaluation? So let's say, for example, that in this case, we're only going to have valid scores if they take more than 20 minutes, okay? So let me grab a new sheet over here. I'm down there on the little plus button. So grab a new sheet and blow it up. I have a very large monitor, but I know that a lot of people are probably looking at smaller monitors and laptops. So let me blow it up for you. So let's call this, let's get our minimum time and let's call it 20 minutes for now. All right, I'm going to name this min time, just like the label that I used. And I'll mark it for myself. Okay. So right now, min time, the value of min time is 20 or 20 minutes. So let's do a quick if then. We're going to compare the time here against the minimum time. So we're going to use our if then to do it. Equals if this time is greater than or equal to min time, then I want to flag it as being a valid score, 1. So in this case, 1 will indicate, yep, it is at least the minimum time. It is a valid score. And for my second parameter, and I hope you can see this, but when I start typing a formula, right underneath the formula, Excel actually tells me what I need to put in. It says if logical test, that's my condition, value of true, value of false. So it tells me what do I need to put into my formula next. So if you can't remember all of the parameters and all the things you have to add, it actually tells you. And not only that, but it puts in bold the parameter you should be including now. So if I back up, right now, it tells me in bold, the next thing I need to put in here is value if true. So if that test is true, what do I put in? In this case, I'll put in 1. And when I hit my comma, I now go to my next parameter, which says value if false, and we're going to put 0. and I'll close it with a parenthesis. So what is this telling me? If E2, that time over there, is greater than or equal to the minimum time that I established, it is valid. Give it a 1 for valid. Otherwise, give it a 0 for not valid. And let's just copy that down. So valid, valid, valid. This one is not valid. 17 minutes is less than the minimum time. Another 17, which is kind of interesting. Here's a 14 and an 18. Another 17, a lot of 17s here. I should have been more creative with my random data. Okay, so how many valids do we have? Well, first, let's name it. Okay, let's name this range because we're going to use it several times for the coming up here. So let's just call it valid. So everything in that range, that entire range, we're going to call it valid. Okay, so let me come back over here. I'm going to rename this results. Okay, so number of valid scores. So, and that would be equals. So I'm going to do the same thing. I just want to count how many of those scores are marked 1. I can do this in 2 ways. Since I'm just using 1 or 0, I can just add up. I can do a sum for that range, just, and get my total number. And every valid score is a 1. So if we add them all up, that tells me my number of valid scores. I could also do a count if valid equals, if it's 1, count it. It's, in this case, it's going to do the exact same thing. So let's just add them, sum. And I'm going to sum up the range, which is valid. So sum valid, 13. So 13 out of 20, or 13 out of however many we've got there, is a valid score. It's actually 18 students. How, we're going to use this number again, so let me just do this. We did this one yesterday, so we're going to go back to our count A. Count A. So count all the cells that have something in them. I'm going to click on data. I'm going to select this entire column. I just click on the A up there and it selects the whole column. And so there it is on the results sheet. Oops, I need to go back where I was. On that column there, let me just close it. Okay, but as we know, it's 19 cells have something in them, but one of those cells is a header. So that's not a student. So let me just add a -1. So we have 18 students. Okay, so 18 out of 13 have valid scores, which is kind of an interesting finding itself, because that means we have 5. We have more than 20%, more than 25% who don't have valid scores. So we might want to think about how can we change the test taking behavior. Well, I'm going to call this cell, I'm going to call it students. How many students? So that cell is now called students. 13 valid scores, 18. So how many? So what percentage, if I can type, have valid scores? Well, the answer to the question is going to be equal this number right here, which I'll just click on, divided by the number of students, 0.722. And let me come up to my home and I'll just hit my little percentage button right there to convert that. 72%. Let's get one more decimal in there. Okay. So only 72% of my kids have valid scores. That's kind of important to know, because basically what happened, right? And that's going to lead to, I think, probably a much more interesting discussion later. Why did only 72% have valid scores? Something went wrong there. Okay. That's what analysis should lead us to. All right, so, well, but it is what it is for these data right here. All right, so we can get rid of valid gain. Actually, I think we can get rid of that. So the question then is, if we have found some students that don't have valid scores, remember we're asking the questions here. If we found some students that don't have valid scores and we want to get rid of them, what is the average of the students who do have valid scores? I don't want to talk about the non-valids because it's not a good measure, okay? So what's the average of the kids that do have valid scores? Well, there's a way to figure that out, which is great and easy. So first of all, let's just find our overall average. Overall average gain. Okay, let's figure out what that number is first. And did I name gains? I did not name this. So let me simplify this. I'm going to give this range a name also. Pretty much just quick tip from having done this for a long time. Any column or any range of information that I'm going to use in analysis, I'm going to give it a name because the formulas are much easier to write and they're much easier to go back and review and understand if you're using real names. So this is my column, this is my range of gains. So we're just going to call this gains. And I just named it up there in the upper left-hand corner. Just type it in, enter. And that is called gains. Okay. So let's find the average of all these numbers right here. Well, to find an average, the formula is just simply called average, which is lovely. And now, if we even look underneath here, average, what are we averaging? We need to put some numbers in here, okay? Well, we want to add up that whole range. So we're going to get the average of everything in the range called gains. And there is our average gain. 14.166 is too many. There we go. 14.17 point gain. But some of those scores are not valid. So we have to do a little modification to our formula. So we did, that one is average, and then it's the range. We could have said average and then just do cell 1, cell 2, you know, if we wanted to pick and choose, but easier if you have a range. So we only want to average the scores that meet a certain criteria. And the criteria is they are a valid score, right? And a valid score is marked by the number 1. So we want to average if they're marked number 1 as a valid score. So our little modification is this, and it's actually pretty simple. Average if. We're going to average it if it meets a criteria. Now, let's see how this is going to work over here. So average of valid scores equals average if, and what Excel is telling me is, okay, what is the range we're going to check to see if we're going to include it? The next thing it's going to ask us is what's the criteria? What are we looking for in that range? And the third thing it's going to ask us is where do we do our averaging? So place to check, you know, the range to check, do we or do we not include it? Range to check. And then what are we looking for in that range? And finally, what is the range to average? So what it's going to do is this. So we're going to say we want to check in this range right here. okay, to see whether or not we include it. And what are we looking for? We're going to look for the number 1, which would indicate it is a valid score. Oops, silly guy. So the range to look into is this one right here. The criteria is it a 1 or not a 1? And if it is, what are we going to average? We're going to average this number over here. So if it's a 1, we're going to include this number right here. This one, it will include that number. 1 includes 8. 0, it's not going to include 0. It's a 0 here. It's not going to include that number. It's not going to include these numbers. It's not going to include that one. It's only going to include them if they meet the criteria, which is, do we have a 1 there or not? Have we marked it as a valid score? So here's what it will look like. So let's see, average range, check criteria, range. Okay. So we are going to say equals average if. Average in the number if it meets the criteria. So what are we going to look in? We're going to look in the range called valid. What are we looking for? The number 1. And if it meets that criteria, then what are we going to average? Gains. I think it was gains. Our average of valid scores is 15.92. Now, if we wanted to take the time to do it manually, we could do that. But I'm not going to. Okay, because Excel just did it for me. And think about this as a time saver. You're looking at the kids in your class or the kids across your school, or you're looking at whatever you're looking at, right? You could go through those manually with your calculator. Just pull up your little calculator and say, all right, it's going to be 70 plus 35 plus 11, and so on like that. And then eventually divide it by the number, okay? But why would you do that when Excel can do it that easily? We named our ranges, and then we just say, look for certain criteria, and if it meets it, include it. And as we see, there's actually quite a big difference between the two. It's a 1.76 difference between those two scores right there. Now, if I'm going to report on student progress, and what was the effect of my instruction? I've been teaching kids. Did they learn anything from me? I am not going to include that number right there. No, sir. I'm going to include that number right there because that's a better indication of whether or not students actually learn something from me. And you see, my result is actually quite a bit better. So far, so good?
Question, super quick.
Yeah.
How do you set the minimum time? It's probably with experience with the test and with your what is it? Your team members?
Yes, sure. Or it might be a discussion with the administrators. I got some kids that went really, really fast. What's the minimum amount of time? You could do an average of the time. No, that'll knock off a lot of kids if you do that. So you probably don't want to do that. You could do a standard deviation and say they can't be less than 1 standard deviation from the average. That might be a good way to do it. But I think ultimately it's experience with the test and discussion with your team members and maybe administrators or, your assessment people or something like that. So how you come up with that number right there could actually be quite important because you want to be able to justify what you've done at some point.
Thank you.
But eventually you get a number, right? Eventually you get a number. But there might be other things besides time that indicates whether or not they're valid. It could be if they scored below a 200, something's wrong there, right? Or whatever the case may be. So there's other ways to do it. I'm only using that as an example to demonstrate it here. Okay, but the question is still, I think, very important. Do you or don't you include those results? So we always want to know, is it a valid score? And I think, yeah, okay, that one talks about IEPs. Okay, so what do I have? A number of scores. We already did it. Valid scores, percentage of valid, average of valid. You know, so we've done that on the other sheet. So let's ignore all that. But the question about standard deviation is actually pretty important. If you have a large enough data set and you have a good test, a good assessment of some kind, you should kind of get a bell curve of results where, you know, it makes a nice smooth bell curve. If it's a legitimate, if it's a valid and reliable test, and you have enough people that take it, enough kids that take it, which means that something like what 66% of your kids would be within one standard deviation, and 95 would be within two, 99 would be within three standard deviations. So it might be important to know, do you have any kids that are just complete outliers? You know, they are beyond that many standard deviations. So it may be important to figure out, well, what is the standard deviation? Now, on this little data set, it's not going to be all that useful. Let me just pop over to the big data set. And do I have anything on gains over here? Time flags, percentile, diagnostics, blah, blah, blah. Not really. Okay. Not really. So if you do need to calculate a standard deviation, this one's really, really simple. The formula for standard deviation, STDEV, standard deviation. And then the parameter is simply, what's the range? Where are we going to, where are the numbers? So if we put in the range, it will give us the standard deviation. You know, how closely clustered or how spread out are people from the average score, basically, is what that's going to tell you. How much do they deviate from the average in general? It's easy to do. So let's do standard deviation. All right. And the formula is, it doesn't make any difference in capitals, but I'm being anal. So sorry. We're going to look in gains. We're going to look in that range. Oops. Gain or gains? Gains. The standard deviation is 19.5, which means that if we have enough data sets, 99% of people should be within three standard deviations. So an upper gain of 58.5. And we're not going to go that far below, but it would be equals that minus that. That'd be the low range, equals that plus that. That'd be the upper range. So 99% of my students should be somewhere between minus 42.6 and plus 74.4. With a small data set, it's kind of ridiculous to do that, even to do a standard deviation. With a large data set, it makes a lot of sense, like the whole grade level of the whole school of the whole district. But the formula is the same regardless. STDEV, gains. And I think that one's on your cheat sheet. I'm pretty sure it is. Okay. We've done all of that. We've done that. We've done that. We've done that. Average gains. Average. Ooh. Okay, so we've been doing some if-thens, right? So over here in our data, we've got an if-then. We look at one condition. We look for one criteria. You know, one condition with one criteria. And if it's true, we do one thing. If it's false, we do the other thing. So that's just our standard equals if, and then we do a condition, a check. If it's true, do this, false, do that. Okay. But, so this is only going to look at one condition. It's only going to do one check, and it's either going to be true or false. But what if you want to check for two things? Like in this case, maybe it's, let's do valid 2. Maybe we want to know, is the gain greater than 0, and is the time greater than some amount? Or we want to say they have to have a valid time here and a valid time here. So both of those need to be over the minimum. We need to check for two conditions, not just one. So if we do if then, like we did initially, we can only check one thing, but we want to check two things. So we need to use a little modification of that, just like we did with average. We did equals average, but then we also did average if. We had a little modification. Here we did if. Now we're going to do something called ifs. IFS. If these things are true, then do this or do that. And it works almost exactly the same. Ifs. It's not going to do my ifs in this one, this version of Excel. So we're going to have to do we're going to have to do it fancier. Okay. We're going to do it the fancy way then. So we said, and actually I like this way better. So, okay. If the condition is true, do this. But what we're going to do when we do this is we're going to check for the second condition. So it's going to look like this. So if the condition is true, then we're going to check if this condition is true. Like that. And if so, then do this. If not, do that. Let me blow this out a little bit bigger. So we can actually put one if statement inside of another one. If this condition is true, then we're going to check the next condition. And if that one's true, we do this. But if this one is not true or that one's not true, then we're going to do that over there. We can put in two conditions. Now there's one little thing that we have to do. Every formula, the parameters are inside a series of parentheses. And we've got one parenthesis over here. We have another parenthesis over here. This one has its own matching parenthesis there. Matches up with that one. But we haven't yet closed the first one, so we actually have to do that. Because this is the second condition we're checking for. And this is the entire formula over here. And I'm only going to do this once and we're going to move on because this will start getting into the weeds. So if valid, no, we're going to do times. If this time is greater than min time, then check the next one. If this time is greater than min time, then 1, if not 0. And I have to put both closures in there. That student meets the minimum time in both. And my minimum time was 20 minutes. So yes, that's over 20 and that's over 20. So they have to have enough time in both tests. And let me just copy that down. Oops. And my falses are going to say those are no's. So then I can come back here and I can count the ones here. And how many ones do I have now? And it's going to be less because I see like here, that one was minimum. That was valid when we only checked one, but it's false when we checked both. That one was valid when we checked one time, but it's false when we checked both times. So there is a way to actually check multiple conditions, and that is how it is done. Let me just, yeah, that's okay. Median mode, skip that. If you want to know the median score equals median and then just the range. Mode equals mode and then the range, which in this case was gains. Okay. Median, what's in the middle of the range? Mode is what's the most common value. Okay. Average ifs. We did average ifs. Yeah. Okay. Skip graphing altogether. Let's do one last quick analysis piece here. One thing we might want to know is, does the amount of time generally produce a better score? The kids who take more time, does that generally mean they're going to have a better score? What is the correlation between time and score? And I think I'm going to do this in the big one because it's going to be much, much more interesting. So we've got, do we have gains for all these? Yeah, we do. All the way down here, we've got gains. And we've got the amount of time over here, which is nice. So let's see if the time and the gains are going to correlate. And let me just grab a sample. Let's do it on the small one. Let's do it on the small one. Okay. The result's not good. It's going to be meaningless. There aren't enough data points, but let's do it anyway, right? Or let's get the total time. Why not? Okay. So total time. And if you're curious, even though I insert a new row and I slid all those other ones to the side, the names for the ranges are still going to be the same. So valid, even though I moved it to the side, is still the same range. Excel will automatically adjust, which is nice. All right, so let's get our total time. So time 2 plus time 1. Okay, and I'll just cheat here. Okay, so there's our total time. Does total time correlate to gains? Well, the standard form of correlation is simply what's called a Pearson product correlation. That's the full name for it. And let me name this total time. Okay, so that range is total time. That range is gained. We're going to see if they're correlated. Well, the correlation is easy. Equals, so it's a Pearson product correlation. That's the standard form of a correlation. P-A-R-S-O-N. So Pearson gives our correlation. And what does Excel tell me? What are my two arrays? Put in array number 1, put in array number 2. So array number 1 is gains, array or range. Number 2 is total time. Is there a correlation? Yeah, but it's very weak. It's actually a negative correlation, a negative 0.15. Now, every correlation, just background knowledge, is going to be somewhere between 0 and 1, or 0 and negative 1. If it's a negative correlation, one goes up and the other goes down. If it's a positive correlation, as one value goes up, the other value goes up. So if it's a positive correlation, more time is going to equal better scores. But we have a negative correlation, which means scores go up when time goes down slightly. It's a very small correlation. If we had like a 0.6, 0.7 or better, I would say it's a pretty strong correlation. This is only a 0.15, so it's a very weak correlation. But the interesting thing is, time goes up, scores go down. Huh, that's very strange. Now, I could redo this and only look at those valid scores. I'm not going to do it now, but there's a way to include some criteria in there. But overall, that's kind of an interesting finding, that as an evaluator or somebody doing the analyses, that's going to raise a question for me. Like, why are the kids with less time doing better? And that would be a question to discuss with my PLC or my administrators. What is actually happening there? So the fun thing about analysis of student data, you get some numbers, right? But you have to kind of think, what do those numbers mean? So I've got a number here of minus 0.15, big deal. I've got a number. That doesn't mean anything. But I have to ask the question, what does that then tell me? Like if I looked at the average valid scores and the overall average, there's a difference there. Okay, it's a different 0.16. But what could that mean, right? So that's where analysis really becomes fun. And this is the kind of stuff you take to your PLC and you kind of ponder at night and scratch your head over and say, what are these numbers actually telling me? And then what do I do about it? Because what's the point of doing any kind of analysis if it doesn't lead to some kind of a decision or action? Switch to big data set, gains, recent times, diagnostic, fancy formulas. Okay, so we've done average gains by valids. That's too fancy than what we need. So what if you just want to know what's the range? What's the highest score and the lowest score? Who got the best score in the class or in this group of tests right here? What's the maximum score or maximum gain? And what's the minimum gain? I mean, it's pretty simple stuff, but who did the best? What's the best score achieved of any students? So let's figure it out. Maximum score. Maximum and minimum both work the same way. Equal, if you want to know the maximum, the formula is called max, and I give it a range. Where am I looking for the scores and what's the highest in that? If I want to know the minimum score, it's just minimum, and then where am I looking? Okay. The maximum within this range or the minimum within that range. So let's just run it real quick. So the maximum score equals max, and the range is gains. 63 was the highest score. Minimum score equals min and gains. I hope you're seeing that by having named ranges, this is so much easier. I mean, really is so much easier. I just have to type in the name. The minimum score was a minus 20. So the difference or the total range is that minus, equals that. Is it minus or plus? Minus. So there's an 83-point difference between the maximum and the minimum score from this very small sample set. And I just did a quick subtraction to find that. Okay. Now, above and below grade level. One of the things that we always want to know about kids is, are they on grade level or not? So the question we want to ask is, how many kids are on grade level? Right? We take some tests. How many kids are on grade level? How many are below grade level? That is a super common analysis. And when we report to the state or we report to the feds or we report to the district, one of the questions is how many of your kids are on grade level? When we look at the state assessment data, the big reading test or the big science or math tests, what gets reported to the general public is the percentage of kids on grade level. So we need to figure that out, right? Well, Excel will do that for us very, very simply. I mean, don't you want to know what percentage of my kids are on grade level, right? And how many are below grade level and need a little work, right? So, what's the way we want to do this? Let's do this a simple. Well, this one already gives it to us. It kind of cheats for us. That one kind of cheats. So let's pretend that isn't there. Watch this. Gone. Okay. I just filled it with black. Well, we have their overall placement. So this student, late first grade. What grade level is the student? Second grade student. Here's his student grade over here. This student is a fifth grade student. What is his? Oh, he's at level 3. So that's 2 kids that are below grade level. Now, I could go through this whole thing and do them one at a time like that, but that would be nuts, frankly. It would be just crazy waste of time to do that. So what if I could convert this information here to a number? And then I can compare that number to the grade level. That would tell me right away how many kids, or whether or not a kid is on grade level. If the number representing this is at or above the grade level number, that student is on grade level. So how am I going to convert this? And I'm only going to do a very small example of this. So let me do this. So here we've got some values. Let me flag them so I know which data set I'm talking about. Okay, so I've got a set of values. I'm going to just copy them out of here and stick them somewhere else. I'm going to put them right here. Okay, copy, paste. So the first thing that I need to do is I need to say what is the numerical equivalent for each of these. So maybe a late first grade is a 1.8. A level 3 is a 3.5. Same again. Level 2 is a 2.5. A 1 is a 1.5. 1.5. Early 3, 3.2. Early K, 0.2. Emerging K, I don't really know what the difference is there between those two, so let's just call it 0. Okay. We do need to get rid of the duplicates. And there's a fancy way to do this. If you want me to show you how to come up with a set of unique values, ask me and I'll do it after the session. But I don't want to get into those weeds now. And let's get rid of, that's also a duplicate. So let me just get rid of them. Okay. So here we've got a set of indicators, and here we have their numerical values over here. So what I want to be able to do is take these and automatically convert them to a number, to that number that I've just put in there. Now I'm only doing a small set. I could do it manually. But if I wanted to do it for the whole thing, I don't want to have to do this 3,108 times, right? It's craziness to do that. I want Excel to do it for me. So let me first put in a new column and placement, let's call it placement value. And let me just expand that out. Okay, so what I want to do is I want to find this item here, which is text, and I want to automatically find out what is the numerical value of that level. So the first thing I'm going to do is I'm going to name this group right here, because this is the range that has the original value and it has the value that I want to compare it to. Okay, so I'm going to name this whole thing and I'll just call it level values. Okay, I'm going to put that up here so I don't forget. Level values. And that's both of these right here. So let me merge them. Okay. So this whole range with 2 columns is called level values. So I want to go through, I want to find the student's score here, and I want to convert it to the second column, which is over here. So I want to look it up. I want to look up in this vertical range, and I want to return the value in the second range. And I'm using those words very carefully. I'm going to look up in this vertical, look up vertical. Those are the two keywords. And I'm going to return the value in the second column. And to do that, strangely enough, I'm going to use something called vertical lookup or VLOOKUP. So I'm going to look up in a vertical range a certain value, and I'm going to return something else. So the first parameter is what to find. What am I looking for, right? The next value is what to find, where to find it, what column to return, and as an option, does it have to be an exact match or not? And in almost every case, the answer is yes. So I'm just going to tell you false. Like if it's not an exact match, then it's going to fail. Okay. So what I'm going to look up, VLOOKUP, I'm going to look up the student's placement. I'm going to look it up in the, what did I call it? Oh, geez. Wow, short-term memory problems. Level values. I'm going to look it up here. I want to return whatever's in the second column, and it must be exact. So false. Okay. So I'm going to look up the value over here, late 1, level 3, level 2, level 1. I'm looking up that. I'm looking for it in this range called level values, and I'm going to return column 2. What to find? The value. Where am I going to look? In the range called level values. And if I find it, what should the answer be? It's whatever's in column 2. Does it have to be exact? What if it's not exact? Then it's false. Okay, so it has to be exact. So here equals, let me blow it up. Okay, equals vertical lookup. What am I looking for? And I can just click on it. That's what I'm looking for. What's X2? Where am I looking? I am looking under level. I'm looking in level values. And if I find it, what do I put here? Whatever's in column 2. And false. Okay. I'll just copy it down. And it automatically is going to give me the numerical values. So a late 1, we said it was a 1.8. We said level 3 is a 3.5 and so forth, right? So it's that VLOOKUP, which is really kind of neat because then you can convert one thing into something else. You're going to convert, in this case, their diagnostic overall placement into something else, a number. And in this case, since we've converted into a number, well, now we've got a number for the placement value, and we've got a number for the grade level over here, wherever it is. There it is. So all I have to do is compare them. Is the placement value a higher or lower number than the student's grade? Let's just do that. Insert. So on grade level, and I'm going to, okay. So let's find out. Equals if this number, the placement value, is equal to or greater than the grade over there, I just clicked on it, then on level. Otherwise, if it's not true, below level. So I'm just going to compare the placement value with the grade level. If it's greater than or equal to it, then they're on level. If not, they're below level. And of these kids, only one of them is on level. Then I can do a count if, how many of them are below level. I can do a count if, how many of them are on level, and I can do an average and so forth. Of this very small set, we've only got one student on level, grade level, which is kind of disappointing actually. So what do we have? So this student, they're 3.2 or early third grade. What's the student's grade level? Third grade. Okay, so they're on or above. Okay. Very, very useful to know because ultimately that's what we're trying to do with our students, right? Get them to or get them above grade level. So we have to find out if we've done it or not. And that's the process right there. Now, where do these values come from? Frankly, I just now made them up. But this would be a good discussion to have. What is the numerical value of, I mean, what does it mean to be late first grade? Or what does it mean to be early third grade? What does that represent, right? And is there a numerical value that you can place on? You have those just kinds of discussions first to come up with the numerical values. And then it's pretty simple to have Excel just run the formula with that V lookup to find out whether or not their placement value is at or above their grade level. And then all we have to do is just count them. Count if, how many are on level. And that's the formula right there. What are we looking for? Where are we going to look for it? And if we find it, what do we return? We're looking for the placement. We're going to look for it here in this range. And if we find it, give me that numerical. So that's how we convert one piece of information into a different piece of information. Now, just as an aside, I've often done this where I've got a named range of 30 or even 40 columns. So I'm going to look for something on one column and I'm going to turn it into something which is 30 or 40 columns later. It really doesn't matter how big your range is. It works exactly the same. Whew. Before we look at classes, oh my goodness. We're going to do one thing here. We've done pretty much everything that I wanted to look at here. But I do want to look, so this is the class group right here. You'll notice that I've got both second and third grade students, and I've got whether or not they're an IEP. So, and we've kind of done this already. I can do an average of students that are not an IEP by grade level. And I can do it with grade level, and I can do it overall. Let me just run that very quickly. Let's call this results. We have already used the formulas that I'm going to do. It's going to be just the average if. So, and let's find their gains. Let's get an overall grade. So let's just average up all their scores. Average of all the scores. And I'll just run that down. Okay. So this is, we're going to call this, we'll just call this grades or scores. Total score. There we go. Total score. Okay. So what I want to know is what is the average score of second graders that do not have an IEP? I've got scores. I've got whether or not they've got an IEP, and I've got their grade levels. So let me first name my ranges. This is, we're going to name this grade. We're going to name this IEP. Okay. So from here, with those named ranges, it becomes very simple. Average score of second grade with no IEP. All right. we're going to use our average if. Average if. What's the range that we're averaging? Ifs. So it's a slight modification, average ifs, because now we're going to look at two criteria. And we see that what it's going to ask us is pretty simple. Equals average ifs. So average if only looks at one. Average ifs looks at more than one. So the very first thing is, what are we going to average up? Range to average. Then we're going to look in the we're going to look for the criterion range 1. And what is the criterion? And then I'm going to have to skip to the next line. Then we're going to look in criterion range 2. And what are we looking for there? And we can put a lot more criterion. So in this case, we know that we're going to average their scores, right? That's what we want to average at the end of the day. The first thing we want to know is, what's their grade level? So the first range that we're going to start checking in is grades. And what are we looking for? 2. Then what's the next criterion range? IEP. And what are we looking for? We're looking for the word no. So we're going to average here if this range is a 2 and if this range is a no. And from here, it becomes really, really simple. Now, is that what I call them? IEP and grade? Yes, no. Okay. So let's find out. Average if. So what are we going to average? We're going to average the scores, I think I called it. What did I call it? Yeah, I know. What did I call it? Total score. Okay. Total score. We're going to average those values. If the range called IEP is a no, and if the grades is a 2. Okay. Name. That means that one of these things I did not use the right name. Oh, it's just simply grade. Okay. So let me go fix that. Not grades, but grade. So the average score of second graders with no IEP is 81.09. But with an IEP equals average. We're going average ifs. We're going to average up the total scores. If the grade is a 2, an IEP, grade is a 2, and the IEP is yes. I got a wrong name again. Grade, IEP, average of total score, not scores. So now I know the difference between my IEP students and my non-IEP students. And that's a pretty big difference. Now, there's a lot more that we can perform on that. We can do the same thing with third grades. We can do the exact same function and compare second grade to third grade, or second grade with no IEP to third grade with no IEP. Because this average if right here, this average if, I can keep stringing out a lot more criteria, but it's going to work exactly the same way. Where am I going to do my averaging if we meet all the criteria? What's the first range I'm going to look at, and what am I looking for? What's the next range I'm looking at, and what am I looking for? And I can keep on stringing them out. I think there is a maximum number that you can do, but it may be somewhere around 64, I think. So more than you're ever going to need, right? And when I have that kind of information, then I can start to make some decisions about this. Is that acceptable to me, that there's such a big difference, for example? And if not, what do I need to do differently? or third graders versus second graders, or whatever I want to do at that point. But it's still just the same formula, which is average ifs. Woof. And I think we are going to skip waiting because we've got 1 minute, basically. If anybody wants to do how to do grading of weighting of grades, like assignment grades versus test grades, like our assignment grades versus our, maybe the assignments are 60% of the grade and tests are 20% or vice versa, I'd be happy to stick around and do that. But I think we've gone over a lot already. Average ifs, if then, if with multiple criteria, standard deviations, mins and maxes. And we've done a lot of things which should give you, with just these few formulas and these few tools, the ability to look pretty deeply into your student data, and most importantly, have Excel do it all for you, so you don't have to pull out your pencil and paper and do it manually. But the key to all of this, as I've said from the very beginning, name your ranges, name your cells. It makes everything much, much easier. So, whew, that was quite a race through a lot of stuff. So, how many of you just had your brains explode again today? I hate to say it. Okay. It's a lot. And frankly, there's a lot more. But I'm going to put the videos up. I encourage you to go back and look at them, because these really are some of the very most common things that we do. And they're, in many ways, they're some of the simplest things that we do when we start analyzing student data with Excel. All right. There's a lot more that we can do. I'm probably not going to do a part 2. I might, but probably not. But if you can at least master and get a good grip on these things that we did yesterday and today, you are going to be able to look very deeply at your student data, which most importantly of all, will then allow you to make decisions about how you're going to help kids learn better, which is the point of doing this. It's fun to do, but that's really the point. How do we look at our student data and turn it into actionable information to help us be better teachers, help our students to be better learners? So thank you all very much. I will say this, I'm going to send around a survey in a day or so. I would ask you to please go ahead and fill it out. I almost hesitate to do that, because one of the questions is the level of the content. How was it? And, but be honest, that's fine. That's fine. Um, my ego will be intact, I promise. But I don't want to leave you shortchanged either. And I'll send around the video links either tomorrow or Monday when I've got them up. And I hope you enjoyed this. And I hope you at least found some tidbits out of this that you would find useful. So
Can I ask a question super quick? I think it might help everyone.
Let me do this real quick. Wow, it's a lot of work. I have some screenshots. Tamara, is this your question?
No, it isn't.
Okay.
But let me know.
Okay. Actually, I'm going to pass on that because we're going to have the full video. So I'll, if it's useful to you, that's great. But you send it to everybody. Yeah. Okay. So if you would like some screenshots that Tamara took, just send her a quick message and ask for them, and you'll send it by email or something, I suppose. Okay. Question.
My question, super quick, was if someone is gracious enough to lend me an Excel document with stuff, is there a way that I can examine a bunch of the formulas at once, or do I have to take the cursor over each one? I don't need you to demo, but
No, there is not.
thank you.
Yeah. Yeah. You got to just click on it and see what's inside of it. Any other questions? We're a few minutes over time. Okay, so I'm going to go ahead and close it. If anybody wants to have like a, hey, how do I do this or how do I do that? I'll stick around. I'll be happy to go through any questions or any other things that you would like me to demonstrate, if you're like, hey, I really would like to know how to learn something, I'll be happy to do that for you. I'll stick around, but otherwise, we are done. So thank you all very much. I hope everybody has a really nice long weekend. Get some rest, and do something to pamper yourselves, because I know that each of you deserves it. Um, Greatly deserves it at this point. So have a great day, and thank you all so much.